Okay, today I'm just here to give you a very brief intro to what surface area is, because that's your lesson for today. As the name implies, it is the area of the surfaces. So we're looking at 3D solids, but we want to be able to see what the two-dimensional surfaces that make up the outside of that is. So we're going to unfold it into a net. Hopefully you've done this in elementary school, and this just kind of serves as a really quick review. So first example, we have a cube. So a cube has squares on the outside, so when we open it into a net, we should see squares. And then how many of them? There end up being 6. So at first here, they don't necessarily look like squares, but that's just kind of the angle that we are looking at it on. There you go, we got ourselves some squares. Okay. Next one we're going to look at is a rectangular prism. So with this one, we do not have equal side lengths like we did before, where we had all 6 equal side lengths or all 4 equal side lengths because it was squares on either side. Now we have rectangles on the sides. So if I were to unfold this one, we get something that looks fairly similar to the last one, but this time instead of squares, they're rectangles. So again, though, if I want to find the surface area, I find the area of all 6 rectangles, and then I add them up. And I can find pairs of sides as well, right? This one and this one are the same. So if I find the area of 1 multiplied by 2, I got both of them. This one and this one are the same. So I find the area of 1 multiplied by 2, I got both of them. This one and this one are the same. Area of 1 multiplied by 2, I got both of them. Add those all up, you got the surface area. Next one we're going to look at is a pyramid. So a pyramid, if we open it up, we actually end up with the base, in this case, is a square, but a pyramid could also be made with a triangle on the bottom. With the square base, we end up with 4 triangles. So the surface area for this one would be the area of a triangle times 4 plus the area of the square. If this were a triangular based prism on the bottom, then it would be area of the base triangle plus area of the 3 other triangles around it, because it would only have 3 going up this side. Okay. Last one I wanted to look at is a triangular based prism. So for a triangular based prism, when I open that one up, I end up getting 2 triangles and then 3 rectangles. And you have to be really careful with triangular based prisms. Sometimes people think that these 3 rectangles are either always the same size, or they think 2 of them are always the same size. That completely depends on what the property of your triangle is for the top and the bottom. If your triangle is isosceles, if this is equal to this, then this guy is going to be equal to this guy. If your triangle is equilateral, if this were the same size too, which it doesn't quite look like it could be, then this would be equal as well, and all 3 rectangles would actually be the same size. If your triangle is scalene and none of these sides are equal, then none of these rectangles are going to be equal either. So when you're finding the areas, you'd have to find rectangle 1, rectangle 2, rectangle 3, find the areas for all of those, add them up, add those to the areas of the 2 triangles, and you've got yourself your area for your surface of your triangular prism. That is it for your intro. Then go on and watch the example videos coming up next.